Howdy! The purpose of this video is to teach you the 3 basic principles you're going to need to be able to rearrange the typical formulas you will use in direct current theory and series and parallel circuits. We will cover more in-depth formula rearranging later into the year when we approach those more formula-driven courses. For now, it's my intention to teach you the skills you need so that you can rearrange these formulas without needing a cheat sheet. Wouldn't that be wonderful? Formula number 1 here is E is equal to I times R. E stands for the electromotive force. That's measured in volts. I is your current, R is your resistance. As this current formula is written, it would only allow you to solve for the volts, E. However, many questions you'll be given, for example, the voltage and the current. Maybe you want to find the resistance. If I put a little semicolon after that and an R, what that indicates is I want you to solve that formula for R. Because the I is multiplied by the R, we have to get rid of the I, isolate the variable of R by doing the opposite. E and I, E equals I times R, is the original formula. I'm going to write that a little bit bigger. E equals I times R. And we're now going to get rid of the I by dividing both sides by I. The purpose of that is to be able to divide I by I, and I divided by I is 1, therefore it'll cancel, leaving you with a new formula of the E divided by I equals resistance. That's a rearranged formula that came from the original, and it is now a new formula that will allow you, if you had the voltage and you had the current, you could find the resistance. So say, for example, the voltage was 40 and the current was 5. 40 divided by 5, you have a resistance of 8 ohms. You could also have solved this formula by solving for I. Let's rewrite the original. E equals I times R. If I wanted to solve for I could divide both sides by R. Same exact concept, getting rid of what you want to get rid of to isolate what you want to isolate. In this case, I want to isolate the I. What's left over after I canceled is E divided by R is equal to I. So the current is found by dividing the resistance into the voltage. The second formula we have is written as a fraction. And we have a new variable not seen in the first example. We now have a P. As you can see on this sheet, P stands for power. Power is measured in watts. So if we're going to start this question off, this formula only works the way it's written for the current of I. If you know the power and you know your voltage, wham bam, you can find your current no trouble. But what if you had the current and you had the voltage and you wanted to find the power? Then you have to rearrange the formula. So I'm going to rewrite the formula, and I'm going to tell you how we're going to solve this for P. So if we solve for P, the very first thing we want to do is to get rid of the bottom of the fraction. Right now, P is divided by E. The opposite of dividing is multiplying. If I multiply both sides by E, then we can get rid of the E on the bottom. Cancel this and cancel this. That leaves us with a new formula, P equals E times I. And now it's what we call more like a linear formula. There's no longer a fraction. So if you were given the voltage E and the current I, you could solve for power. What if you want to solve for E? In the original equation, E was on the bottom. Not an ideal spot for a variable that you want to solve for. But in the second version of the formula, E is already up on the main level, so to speak. If you want to solve for E now, and E is right beside the I multiplied together, then the opposite would be to divide by both sides by what you want to get rid of. In this case, you're going to want to get rid of the I. So if I divide, I'll rewrite my formula. E times I equals P. Divided by both sides by I, I'm left with a new formula that states that E, electromotive force, or the volts, is found by taking power and dividing by the current, P over I. P over I. That's messy, and I don't know how to fix it. P over I. If you look up here in the power wheel in the top right-hand corner, you will see that a lot of this information can be found up here in what we call the power wheel. If you want to find E, E is equal to I times R. There's one version up there. If you want to find E, you can use this one, P over I. There's a second version. If you want to solve for P, power can be E times I, right here. If you want to solve for R, and so on, we solve it to be E over I, right here, and so on. The next page has two more formulas and another principle for us to learn. Formula number 3 is another one for power, read a little bit bigger. Power is found by taking the current I squared and timesing it by the resistance. So if you know the current and the resistance, you can certainly find the power. What if you know the power and you know the current and you want to find the resistance? Well, you can manipulate the formula. Rearrange the formula to solve for the variable you want to solve for, which is all what we call rearranging formulas. I'll write it over here. P equals I squared R. If you want to solve for R, the R right now is multiplied by I squared. The opposite of multiplying is to divide. If I divide this side, the right-hand side of the equation, by I squared, if I divide the left-hand side by I squared, the I squareds will cancel, leaving you with an isolated variable of R on one side of the equation and P divided by I squared on the other side. That is exactly the same thing as saying R equals P over I squared. It doesn't matter if the isolated variable is on the left or the right, as long as it's by itself. You may be asking, what would happen if? What would happen if you want to solve for not the R, but the I squared? So say we rewrite the formula. P equals I squared R. And you want to solve for I, let's just say. Well, that is a double whammy, a two-stepper. But we always follow the steps. The first step would be to get rid of the R. I squared times R. The opposite would be to divide both sides by R. And then you'd be left with an almost finished equation. I squared equals P over R. But we're not done. We need to solve for I. And the opposite of a square in math is the square root. So if you want to get the I by itself, you need to do another step. I take the square root of both sides. That will allow me to cancel the root sign and the square sign. Let me go off on a tangent for a second. If I take the number, I'll do this one on the next page. Let's say the square root of 16. You probably know the answer. The square root of 16 is equal to 4 because 16 is 4 squared. So the number under the root sign, when you square it and take the square root function, they cancel each other out. So the square root of 16 is 4. The square root, say, of 49, you may recall, in a previous life, would be 7, because the square root of 49 is written as 7 squared. So square root and square cancel each other out, leaving you with the final rearranged formula of I equals, no longer squared, just I equals the square root of P over R. And the one that I scratched out, we'll do it on the next page. E equals the square root of P. E equals the square root of, or P times R, doesn't really matter. Maybe a little confusing there if I use a dot or an X. Some texts are very careful not to use an X because it looks like an X and it can be confusing. But an X and a dot mean the same thing in this situation. Okay, so this formula that I've written down here only works if you want to solve for E, the voltage. If you're required, for example, to solve for the P or the R, the power or the resistance, you would have to get at those letters which are currently trapped under a square root sign. As we just learned, a root sign and a square are the opposite function. So if I squared the right, square root and a square, basically if I times it by itself, they nullify each other. I can do that as long as I also square the left-hand side. What does that do to me? I now have a voltage squared equals simply power times resistance, which is no longer trapped under a root sign. So if my job here is to solve for power, then I would get rid of my resistance. So if I circle the power, I want to get the power by itself, I'm going to get rid of the R. So I'm going to divide both sides by R, and I would be left with a new formula that stated power can be found by taking the square of the voltage and dividing by the resistance. At this stage, I could have also taken the formula E squared equals P times R, and I could also have solved, say, for the resistance, not the power. And if I did that, I would divide by what I want to get rid of, the P, and cancel. So the resistance will be found by taking the voltage squared dividing by the power. And now you have three formulas, that one, this one, and the original, which was E equals the square root of P times R. All three of those formulas are identical in that they all work with the same variables, and you really only need to know one to find the other two. And in my opinion, you shouldn't memorize three formulas when one formula will do. The last formula at the top here is Kirchhoff's voltage law, which basically states that the sum total of the volts would have to equal, the total voltage would have to equal the sum of all the voltage drops in your series. If I want to solve, say, for V2, this formula is perfect. But what if I want to solve, I'm sorry, I said that wrong. If I want to solve for V total, this formula is great. But quite often, you know the total voltage, and you want to find one of the individual voltages. So say I want to solve for not the V total, but say V2, or V1, or V3. Doesn't matter, the procedure will be exactly the same. The difference in this question is the variables are not multiplied together, they're not divided, they're not square rooted or squared, they are added. So the opposite would be to subtract. So I'm going to have to move the V1 over and the V3 to the other side of the equation. When they come over, they're going to have to turn into its opposite function, operation, so to speak. So the V total was here first. That's the big number. Subtract the V1, subtract the V3 would give you the V2. So you should be aware that not all formulas are just multiplying and dividing. Sometimes you have some adding and subtracting in there as well. One more quick thing that might help you later. I'm going to rewrite the formula at the end that we started off with. I'm going to rewrite the formula E is equal to I times R. Okay, the voltage is equal to the current times the resistance. Let's say that the current is equal to 5 amps. And let's say that the resistance is equal to 8 ohms. The symbol for ohms is a Greek symbol, omega. That's messy, but that's kind of close. So you could easily solve for the E. 5 times 8, the voltage in this case would be 40 volts. No trouble at all. E equals 40 volts. Use those nice, simple numbers and think about how they would play into when you manipulate a formula. So if you know, I'm going to take that V out of there. Can I do that? Let me just do what I do know how to do and take that V out. I'm going to do this. 40 equals 5 times 8. That's an equation we know to be true. So here's another way to think about a problem-solving skill. If you knew the E and you knew the I and you had to solve for the R, you would know that 40 divided by 5 gives you 8. If you knew the E and you knew the R, 40 and 8, you could solve for the 5, which would be the current. So my suggestion is pick some numbers, plug them in, and teach yourself how to manipulate formulas if you have to by doing number rearrangements. Sometimes that helps because you could prove that 40 divided by 5 would equal 8 in that scenario. And the same thing is true with the more complicated ones, with power and with the square roots. I can do just to throw it out there at you. Let's look at the one power equals I squared R. And you were asked to solve for the I. So if you're going to solve for the I one more time, you divide by the R, clear it, you'll be left with I squared, the current squared, power divided by resistance. Okay, if we want to get the I by itself, we have to do the opposite of a square, which is the square root. And now we're going to have left, because they're going to cancel, the current is equal to the square root of power minus resistance. So let's just say I told you that the power was 200 watts and that the resistance is still equal to 8 ohms. Let's plug it in. So 200 divided by 8, and then square root is how you find the current. If your thinking cap's on, the current should be equal to 5. Let's see why. 200 divided by 8 is going to be, I'll continue up here, 200 divided by 8 is going to be the square root of 25. The last step, 5 is the value, so 5 amps would be your current. Okay, don't forget that formulas represent something, and the somethings are numbers, and those numbers will give your formulas more meaning if you apply numbers and try them. Hope this helps you to get your feet wet with rearranging formulas, and I hope you do not rely on the power wheel or formula sheets, and you have a little more confidence now in rearranging the formulas. Just remember the opposites. When you multiply, you divide. When you divide, you multiply. When you square root. And when you add, you subtract. Good luck to you all.